Why, hello there, and welcome to another Monday, PBS. Okay, I know that was a little bit over the top. Couple things to note before we start. You guys do not have school on Friday or on Monday of next week. That means you will not be getting an assignment on Friday or on the following Monday. Now, also, since we're doing distance learning, I'm not going to have anything due on those days either. So you can enjoy a full 4-day weekend. So yeah, just a heads up on that. What we're going to talk about today is 5.1.6 lines of defense. Basically, this is going to sum up about what happens if you do get sick with a bacterial infection or a viral infection. How does your body respond to it, and the various organs that play a role. We've already kind of talked about body systems earlier in the year, if you remember that. That was a long time ago. But these are going to be the main organs that are going to be involved in our immune system: the tonsils, adenoids, lymph nodes. If you've ever been sick and you go into the doctors and they start feeling down like right underneath your jawline and feeling for bumps, they're actually looking for your lymph nodes, your thymus, spleen, etc. And some of you usually ask this in class, some of you might not even have your appendix anymore because that can be removed. There are going to be two different types of defense that your body has. The very first one that we're going to talk about is called the nonspecific defense. That's going to be basically your first line of defense. Nonspecific is just what it sounds like. It protects you from all types of various bacteria and viruses. This also is if like you ever get a splinter, your body will actually break down that splinter if you don't remove it. This line of defense doesn't remember or focus on specifics. So like if you have ever gotten a sinus infection, the first non-specific defense isn't going to remember that you've had it already before. It's basically, it forgets everything, for the lack of better terms. The very first line of a non-specific defense is your skin. That's what keeps everything in your body and keeps everything out. However, your skin has various holes. This is why the media with the COVID-19 has been talking about do not touch your face, because the viruses and bacteria can enter your body through your mouth, through your eyes, basically any kind of mucous membranes. And that mucus that's inside your nose, if you ever have a runny nose, that helps trap the foreign objects and helps get rid of them. So that's the purpose of it. Your nose hairs help filter the air. And then again, your stomach is very acidic, will help try to break down the pathogens, as well as your tears. If you ever got something stuck in your eye, like right now there's a lot of gnats outside. If you get one in your eye, you'll start crying and it'll remove the gnat. And I mean, I love my immune system. Who else loves their immune system? Antibody? Huh? Antibody? Oh, bombed. All right, getting past that cringe. Our second line of non-specific defense is inflammation or fever. Most of you probably have had fevers in your life. That's usually a sign of some kind of infection, whether it's bacterial or viral. And what happens is, with inflammation and fevers, blood rushes to the area and it brings phagocytes and other white blood cells, and that tries to keep that infection just to one area. Most viruses and most bacteria do not respond to heat very well. So that's why your body creates a fever. It is literally trying to burn the virus or burn the bacteria out of you. Second part of a second line is phagocytes and proteins. They have receptors on their outsides that seek out the bad foreign invaders. And then once bound, the phagocyte basically surrounds it and eats it. So that was it for the non-specific defense. Again, just a reminder, non-specific, basically, it doesn't target any one specific virus or bacteria. It's a general protection. Moving on to specific defense, this is where we create antigens and antibodies to protect us from a specific viral infection, such as like chicken pox, or if you ever got a vaccine, the vaccine contains antigens and antibodies to prevent the measles virus from infecting you. This comes into play after the invader gets past your non-specific defenses. So again, if it gets past your non-specific defense, this is the next step. The two main cells involved in this are the T cells and B cells. T cells are pretty cool. They're like the Terminator cells of your body. They will seek out and destroy everything. And they won't stop. That's their whole purpose, is to destroy. And how they work is they kind of work in tandem with beta cells. What happens is bacteria or the virus, like in this picture, gets into your body. It matches up with a B cell. What happens after they match up is you can see the antigen connects to the B cell. The B cell absorbs the antigen. The antigen gets processed, and then starts after it's processed, it gets displayed on the outside. What happens next is an activated helper T cell, again, kind of like a Terminator cell, comes over, sees that presented antigen, and basically destroys it. And what happens is what's left over goes to the plasma cell, and the plasma cell creates the antibodies, and that's what prevents you from getting sick in the future and helps destroy whatever bacteria or virus is left in your body. Antigens themselves are proteins on the pathogens, and that tells human cells what they are. It's like an ID card or your student ID card. The phagocyte presents the antigen to helper T cells, and again, that's what produce proteins activate the B cells. All right, our B cells are activated by our Terminator cells and also connects to pathogen antigens. The B cells produce the plasma cells that make the antibodies. The antibodies attach to the antigen and mark it for destruction. This is where specific and non-specific are a little bit different again. With specific, the B cells also make memory cells that remember the same antigen. So if you ever get infected by the exact same bacteria, your body will respond much faster. Lately in the news with the COVID-19, they are not sure if our body will create these memory cells or not. There's been some evidence that shows that it doesn't, and some evidence that shows that it does. So there's more studies being done on it as we speak. There are two different types of immunity. There's what's called adaptive immunity and innate immunity. Adaptive is very specific to individual antigens or types of antigens. There's typically a little bit of a lag time from exposure to response, so that means you'll feel like crap for a little bit and then you'll slowly get better. But it does create a memory of that infections. There's two different types of ways that the adaptive immunity occurs, humoral and cellular. The two types of cells that help with adaptive are the T cells and B cells, like we talked about, and then the humoral is the antibodies and cytokines. Those are what kind of goes around through your bloodstream when you're sick. Innate immunity is non-specific, very, very general immediate response, so it's going to try to get rid of it right away, so you might not even realize you've been infected by a type of bacteria or type of virus, but it doesn't remember the infection for later on. Again, the types of cells that help with this are the phagocytes and natural killer cells, and then humoral, there's pattern receptors on your cells, complement enzymes, and again, cytokines. There is this crash course immune system video. You do not need to watch that for today on Monday. That will be your homework assignment on Tuesday. I will have it posted in the Tuesday folder if you do want to watch it tomorrow so you can work ahead, but that is up to you. Here's a flow chart with the immune system that shows the differences between acquired and innate. Again, just take a peek at this. Not going to necessarily talk very specifically about this on the test. We will go into the various types of phagocytes later in the week, but that's really about it that I want you to know from this. Again, a picture just kind of shows how your body responds. So just take a peek. I'm not going to have this on the test. And basically, that's how the immune system works. This research information is all extra, so you do not need to actually do anything with this. Some students have asked for more information on the immune system, so I'm giving it to you guys. And that is it for the notes for the day. You do have a short little video to watch. That video is in the daily folder. It's a Ed puzzle. It's about 6 minutes long. I think there's 8 questions, all multiple choice in it. And that wraps up our TED Talk. Thank you for coming.